Hello, my name is Jesus Mendoza and my teammate Leonardo Jaimes, and we're going to present our final challenge, extended normal filter with puzzlebot. Let's start.
So when do we use the extended gamma filter? We use it with nonlinear systems and when we need to estimate our state. We can also calculate the orientation based on the odometry and a known reference. In this case, we used Arucos. And we can see the equation of the new estimated state that uses the prediction of the previous state, the common gain, and the observation of any market at any time, and the observation model. We can also see our node that receives the left and right wheel velocity, the time, and the Aruco pose, and then it performs the prediction using the differential motion model, and we validate if there is a valid Aruco market. If yes, we correct the pose with the filter, and if not, we publish the transformations, odometry, and joint states.
Then we have the block 2 algorithm. We use that algorithm to our puzzlebot that allows them to reach a goal while avoiding obstacles. We also have our state machine that have 4 different states. First of all, we have our stop robot state that stops the robot, then the oriented wall that align orientation based on the goal, then we have go to goal that advance in a straight line, and follow wall that goes around the obstacle.
And then we have our nodes communication. We can see that there is the path generator who generates the points target and it publishes it to block 2. And we can see that the block 2 publishes the command velocity to Gazebo, and we receive the scan topic from Gazebo in order to avoid the obstacles. Then with Aruco View, we receive the topic camera so we can process the images and identify the Arucos. All this information is published in Arbis, so we can see the simulation there.
Okay, during our challenge, we face a lot of different troubles. For example, the integration between all system models, for example, Kalman filter with the odometry node and also path generator, and we have many troubles in all that different simulations. So these challenges were addressed through constant validation and adjustment of each model. We make a lot of different simulations and we try to correct our mistakes. And
we have the metrics. We use 2 metrics here. As an example, on the left side, we have the orientation comparison between the real robot and the estimated robot. We can see that the difference are really low. So there is practically no difference between those 2 robots. And on the left, we have the error of the estimated trajectory, in which we can see that the trajectory is practically the same, only with a few errors. And as conclusions, we can say that this was a really challenging work. The most difficult part was to calibrate correctly the block 2 algorithm. We needed to do a lot of tests in order to find the best calibrations for our robots.
Thank you.